Hi, my name is Indumati, and this is my student ID. And I'm going to talk about the CPU stimulation, which we did part of the hackathon event last Monday. And I've created a PowerPoint presentation about what we did, what is an efficiency core, what is an performance core, and how it's going to work out with the Apple Silicon architecture. Let me go ahead and share my screen, and I'm gonna put my ID down. Share my screen. Yes. So let me get to the, yeah. So this is the PPT, and yeah, um, the objective of this CPU simulation was to identify how much of energy and how much of energy it's gonna a process to take up per CPU cycle, and depending upon the difficulty. And that's what our objective is gonna be about, to simulate a CPU with different cores, which is the efficiency core, and then the performance core. Based upon the difficulty, it would be put on the, if the difficulty is higher, then it would be put on a performance score. If the difficulty is going to be lower, then it's going to be put on the efficiency course. And the process of creating those tasks vary upon the difficulty, like I said, and how much of time and how much of energy. The energy would be the battery, and time would be the processing speed. So it's going to be, uh, that's what we are going to measure and we are going to understand. So, like I mentioned, the performance score does have a high speed, and it's going to drain the battery faster. But the efficiency course, the speed is going to be low, but then the battery would be efficient. So the scheduler assigns each processes to the course based upon the difficulty. Like I said, let's say 1, 2, 3, 4, 5. There were 5 different processes. Like two being the cutoff, or the threshold, which measures it's going to be a difficult or not. Then based upon that, if um, 5 would be put on the performance score and 1 would be put on the efficiency score, depending upon how much of difficult it is. And next slide is going to talk about the classes that I created, part of the Python program which we use to create the simulation. So the first one would be the process, and second would be the first class that I created is about the process, which has the ID, and then which is the task ID, and then the difficulty, how difficult it is, and the core type, whether it's a performance core, whether it's an efficiency core, and how much of it energy is remaining. So that would be defined in the process. And when coming to the core, you would have the different types, the speed and the energy multiplier, and then which the current task it is holding. And then finally, the other class would be the CPU simulation, which manages the list of cores and assigns the task. Let's say if there are two performance cores and two energy, sorry, two performance cores and two efficient cores, two performance cores and two efficiency cores. In that case, two are being busy, then the one which is being expected to be on performance score would be put on queue. So all those would be assigned. All those how it's gonna we are gonna simulate is would be defined in the CPU simulation. Yeah. So depending upon, I think this also talks about the same. I have another Word document which discusses about what each class has and what each methods within the class has and how it's going to do and what it's going to do. So I'm going to talk about it in just a minute. So yeah, based upon the difficulty, if it's difficult, then it will be put on performance score. If it's the other, then it's going to be on the efficiency score. And the unassigned tasks, which are there, which requires attention, would be put on the queue, and then the completed processes, by end of it, the completed processes will be logged And then, yeah, let me pull up the flow, the program flow. So this is the program flow. So like I mentioned in the PPT, we have process class, we have a core class, we have CP simulation, and then obviously the main. The process task, like I mentioned, it has difficulty, the total amount of work that needs to be done, and the remaining work that needs to be done, left to be complete, we defined here, and the task ID like task 1, task 2, task 3, and then the code type, whether it's in performance core or efficiency core, the process needs to be assigned to. And then second class would be the core. This is where how much speed and energy it's going to be used per cycle and which one is currently assigned, like collectively how much of energy it has consumed and how much has been saved. All those would be defined inside the core class. And within the core class, there are important methods such as assign process and the run cycle. The assign processes assigns the processes to the score, like whether it's a performance score or it's an efficiency score. This method is going to assign those processes to the core. And then obviously the run cycle, based upon how what the difficulty of the task or the processes, it's gonna assign the work to the respective core, and then how much of energy is going to be used all will be defined here. And then next would be the CPU simulation class. This is where it creates a pool between the performance and the efficiency cores, and then it maintains a queue. Let's say there are only two performance cores and two efficiency cores, but three of the processes require the performance core, and two have been obviously used, so one will be put on the queue. So that is where we are going to define how the queuing process works, and what to be, like I mentioned, what based upon the difficulty, the cutoff goes to the performance score or else it goes to the efficiency score. So all those will be defined in the CPU simulation class, and the history of each cycle would be resulted in the reporting as the final output. And then the main method, that's where it calls from. So the step assigns the task and runs one CPU cycle and logs the results. And then the run method, it keeps calling the step until all the tasks, like all the processes, have been finished. It keeps calling this step uh, method. And then the report would be the final usage of how much energy and how much time, I mean, how much energy and how much, what's the speed and how many logs per cycle, all would be defined in the main method. Now I'm going to grab the debugger real quick, and then we are going to run and see one process. Okay, so like I just explained about, like each class is being defined with the different set of activities that needs to be done, like the process class, the core class, the CPU simulation, and then the main method from which it gets called to. So we are gonna run. I can just brief out what is being done here. Like like I mentioned, the difficulty and the remaining work needs to be done, and then which type of code type, and then the ID. And then the next would be the core class, which should represent which either the performance or the efficiency core is being used on, and it assigns the task based upon the cutoff or the threshold, which we are going to define right now in this process. And then the run cycle, is that is where it's gonna run one process code per one process per core, and then return the log. And then the CPU simulation just manages the whole simulation. And yeah, so this is where what is unassigned and what is assigned, and which needs to be on queue, and yeah, all these. When it is busy, then we are gonna put it on queue. When it's freed up, then we are gonna pick it up from the queue, and then we are gonna assign it to the respective core. And then these are some print statements. And then this is the main program, and I'm gonna run this process now. Yeah, so I'm just gonna give how much of performance code. Let's like we talked about in the presentation, let's take we have two performance scores and then two efficiency scores, and then the multiplier, let's say 1.5, and then the energy usage would be 1.33. That would be usually the energy usage would be around 1. You're just going to be adding 30% higher to what it is, what it's usually going to take. So it's going to be 1.33. And then now it's going to be the efficiency core speed. So efficiency score speed would be 1. Let's put on 1. And then let's try with different numbers too. And then the efficiency core usage would be also 1. And then let's set the difficulty cutoff to be 3, and then yeah, 3, and then we are going to enter different processes. So 5, 2, oh sorry, 3, 2, 4. I'm gonna enter all the difficulty ones, and then 1, 2, 3, 2, 1. Now our process ran, and then we have two performance scores, two efficiency scores. The energy usage was around 23.31, and then the CPU cycles were 7. Yeah, it totally were for all the processes that we created. We had total 7 CPU cycles. So the difficult one, the complex one, which is number 5, that was put on the performance score first, and then the next complex one, which was 4, that was also put on the complex 4. I mean, put on the performance score like 2, and then the less difficult ones, which is 3, 2, 1, was put on the efficiency course. If you see 3, and this is 2. Yeah, those were put on the efficiency course. Since we specified the speed, right, the speed should be 1.5 times. For the performance score, and for the efficiency core, it is going to be 1. And then the energy usage, which is the battery usage, which is 1.33, and then the efficiency energy usage would be 1. So it took 7 CPU cycles, and the energy utilized was around 23.31. We can also try with another set of simulation too. Let's take, let's maybe we can try reducing the speed and the energy, and then try seeing how much of energy and how much of what's the speed and how much cycles it took. We can validate that. So I'm gonna run the process again. So this time I'm gonna still hold on to two performance cores, and I'm gonna hold on to two efficiency cores. This time the speed is gonna be let's keep it to 2, and then let's try the energy to be 1, and then that is for the performance speed and energy. Now we are going to talk about the efficiency core. Let's say the speed to be 1, and then the energy usage should be 0.8. Let's take that. So we have increased the speed to 2, and then we have decreased the energy to 1. That means it's just the opposite of what the performance score needs to do. But yeah, we are going to do that. And then I'm going to enter the difficulty. I'm going to keep it as 3, and then I'm going to enter 5, 4, 3, 2, 1, 1, 2, 3, and then 4. It took 7 cycles, but the energy usage is 16.6 because we did have the energy usage set as 1, and then the total cycles it took was around 7 cycles. But since we altered the energy and the speed, we could see being more efficient compared to the previous one. The energy usage was much better because we did take up the energy levels to be set to be 1, and then the speed to be 2. But if we do the opposite of it, then it's going to take up more energy, and then the cycles, obviously, because we are just giving it to be the same, right? So yeah, it's going to work out that way. That's what we did. We did, as part of the hackathon project, we did try to create a different processes with difficulty levels, like 5 being the high and like the difficult one, and 1 being the least difficult. And then we did try seeing simulating with different putting them on different cores, which is the performance and the efficiency course, to see how the process works and how much of energy it's going to drain, or how fast it is. Like last time when we see the process, the toughest one, the 5, took around like was put again on performance code 2, and then it took around like more than 4 cycles. But this time, since the speed is multiplied even more, like 50% higher than the last time, which was 1.5, which is given 1.5. We could see the process getting completed within 3 cycles, and then the next task was taken up and then it was run. So yeah, this is the complex one was put on the performance course, and the less complex ones, which is 3 and 2, was put on 3, 2, 1 was put on the efficiency course. So this is about the project, and finally, to conclude, start and I've defined the start and end time of each task, and then total time it took and total energy it consumed was displayed as part of the project that I created. Thank you for this project, Dr. Littman. It was a nice understanding and a good way of learning about the performance and efficiency course, rather than just being learning about it more on, I mean, more academically. It was just like a hands-on. So it was a good learning process for me. Thank you so much for that. I'm going to stop the recording now.